Thank you all for being here, for having me, and thank you all for the patience. Originally, as you can see in the bottom of the slide, I was not supposed to be here or give this talk. My friend and colleague Paul Scholes was supposed to be here, so first and foremost, I want to relay his apologies. He fell ill, he's a parent, and some other stuff, so I think he's just had a lot to work through, but he sends his apologies and is really excited for this meeting to happen. I'm very much hoping to help contribute to any discussion. So if and when you ever want to reach out to Paul, given things that I'm going to present, please feel free to do so. He was very much wanting to be here. So I wanted to make that clear. But yeah, I'm Emmanuel. I work as a professor at WVU. And given the theme that I perceived this morning's session was going to be, I wanted to focus on what is oftentimes thought of as the succeeding telescope to CHIME, which I believe folks have spoken about to some extent, which is called CHORD, standing for the Canadian Hydrogen Observatory and Radio Transient Detector. So I'll go through just a few things in terms of introducing the actual design of the instrument, and then move on to the way in which it's being designed and how that design is being informed by the science cases, and then go into a little bit of forecasting, what folks have currently been doing or actively doing, to get a sense as to what CHORD will do for FRB science or transient science in general, and end on an update as to its current status. So first, the introduction. In terms of what the observatory will look like, this is sort of the latest version of this graphic or figure showing the overall setup of the CHORD observatory. So it'll consist of two major components. There are three shown here, but the major component will be what's called the core array. It'll be 512 6-meter dishes, all kind of stacked together in this square-like pattern, and will actually reside next to CHIME. So it's not even just shown there for scale. It's actually going to be sitting next to the CHIME telescope at the DRAO, the Dominion Radio Astrophysical Observatory. So this will be the main, essentially the detector itself, so to speak, the thing that will issue triggers for follow-up, etc., will come from this core array. But along with the core array, there will be at least 2 outrigger stations that we are in the process of acquiring the funds to build, or at least finish specking out the designs to build, located at other radio observatories. On the west coast, it will be located in Hat Creek, California, and towards the east coast, it'll be located at Green Bank Observatory, which is a beautiful place and not too far from here. There we go. And the outrigger stations themselves will be smaller scale versions. Instead of 512 dishes, it'll be 64. But that number is essentially ensuring that whatever signal can be detected with some signal-to-noise threshold, so to speak, at the main core array, we can adequately detect even if marginally at the outrigger stations. And the baselines, as you can figure, are there to enable very long baseline interferometry with the purpose of localizing these signals. CHORD is actually an even bigger collaboration of different groups and people that span several continents at this point. The major players are all shown here. Most of these institutions are located within Canada, of course, from which the support largely comes from the Canadian government. But over the past couple of years, folks in Italy, and specifically with the INF Research Center, have acquired substantial funds and are actually buoying the development of core technology. And so as you can see here, there are various institutions that span North America as well as parts of Europe looking to achieve the spec design. Now, speaking of the design, like I said, the instrument is meant to be, in some sense, a successor to CHIME, but what's kind of awkward is that CHIME and CHORD are meant to operate together for reasons that I'll mention in a moment. But like CHIME, CHORD is being designed to enable a wide variety of science cases at the same time. So in that sense, I say CHORD is its successor to CHIME in the sense that it's meant to enable and will enable what's oftentimes referred to as commensal science, right? The observatory will be on, digitizing the radio sky, and various groups and folks will put in their instruments to tap into the same data stream and do what they want with them, all at the same time. And I only show several of the science cases here, but again, there's a lot of other science cases not being shown here as well. But the primary drivers are arguably these 3 settings, but the one I'm talking about focusing on radio transients with applications to FRBs. And again, when I say successor to CHIME, CHORD is in the process and has been in the process of developing new technologies, whether it's a wider field, a wider bandwidth radio antenna, the underlying digitizing technology to actually handle even larger data rates that are expected for CHORD in comparison to CHIME. There's a bunch of different things that folks have been working on over the past 3 to 5 years at least in order to enable CHORD to be a novel and, again, improved instrument for wide field continuous survey instruments, with the goal of essentially maximizing the available survey speed for the CHORD Observatory. So again, there's a lot of developments, some of which I mentioned here, but I highlight in the top table that, again, in principle, and even through the design, CHORD is expected to produce a data rate larger than that of the SKA, that isn't online yet, but will be soon, of course. And the idea is that there's a lot of development going on, and has been going on, to handle that data rate and extract as much science as we can. Now, probably for the purposes of all sorts of different folks here, observers and theorists and everywhere in between, it's natural to wonder in what ways does CHORD improve upon CHIME, or how do they compare? So I put the main points here. In terms of a visual representation, I oftentimes people like to show these sorts of plots here. So this plot on this panel on the left shows essentially the instantaneous field of view of CHIME. Right? So CHIME, the way it's designed, is it spans roughly 200 square degrees of the sky in this columnar-like pattern here. And it's hard to tell, but there's actually dots here representing individual tidal ray beams that are essentially pointing in different parts of the sky. Whereas CHORD will instead focus all of its beams within its field of view, which is, in that sense, a bit smaller, and more concentrated into this circular pattern. Despite that essential decrease in the field of view, though, there's substantial improvements, such as twice as much finer frequency resolution, 3 times as much receiver bandwidth that goes from 300 megahertz to 1500 megahertz, which again is much larger than the 400 to 800 megahertz for CHIME. And given these designs, along with other technological advancements at the front end, the overall sensitivity is expected to be increased by a factor of at least 4. And so, despite a general decrease in field of view, this increase in sensitivity will nonetheless allow us to detect more FRBs than CHIME will. And again, there's a lot of details and works that have even begun to be published with regards to the ways in which the dishes themselves are designed in order to minimize all of these sorts of instrumental effects that we encounter with CHIME. Given the chromaticity, the fact that it's such a wide bandwidth in the field of view, or wide bandwidth, rather, there's all these interesting instrumental effects at play that, again, the instrument is being designed to help mitigate. Now, for a quick summary of forecasting, again, you probably have seen plots like this that show the various instruments and where you place them and where you place the next generation instruments that are presumably going to go to larger number of detections per day, better localizations, etc. But in terms of the specifications as well as the achievements and technologies that we're making, it seems realistic that CHORD will actually detect, localize, and expand upon the known population, both in terms of numbers and access to astrophysical information. So given the sensitivity of CHORD and the fact that various things like the receivers and the analog chains, etc., are indeed working out in the ways that people are expecting, we will realistically detect at least anywhere between 10 to 50 FRBs per day at the CHORD array. Right? So it's a factor of at least 5 improvement on average, give or take how nature feels on any given day. In comparison to CHIME, but again, given the fact that CHORD is actually meant to and will include the outrigger stations, among those 10 to 50, 10 to 20 of those will basically have, if not instantaneous, then at least near immediate localizations of their sky positions to within 50 milliarcsecond precision, given the timing baselines, the sensitivity, etc. And as I'll show in a moment, again, when folks have done a population synthesis sort of forecasting, right, given all sorts of assumed parameters of the underlying distributions, it seems like we'll be able to push the redshift range, so to speak, of FRBs that we get out to 3 to 4 at least, which starts to give interesting prospects towards gauging all sorts of things, whether it be helium reionization or even just other cosmological applications that are not yet possible with CHIME, given the requirements or the needed data points for such things. Now here's some work done by Seth Siegel, again, taking some model of the overall intrinsic population of assumed population of FRBs throughout the cosmos, and then feeding that through the black box that is the CHORD instrument. In terms of what's generally expected, we're expecting to see results like this, where the blue histograms are detections with CHORD, the red are those with CHIME, and you can see an overall improvement in terms of numbers, a shifting of means or medians of distribution out to lower fluences, so fainter sources naturally will be able to see better, of course, with the improved sensitivity. The amounts of redshift information we expect to expand dramatically. The ranges of dispersion measures, for example, we expect to also see with much more improved statistics and so on. But folks have, again, are in the process of doing additional forecasting in different ways, and so here's some snapshots of work being undertaken by Moss and Salmons or McGill, who's really interested in seeing what CHORD could do for detecting lens galaxies, or at least cluster lenses, basically, and how FRBs can be used to see reflections of those effects in FRB data. And one of those snapshots just shows, again, another way of representing the plots I showed before, in what ways CHORD will expand upon CHIME in terms of the access that we'll get to the much more distant, fainter population of sources that are presumably out much farther away. So I encourage you to tune into those works that I showed because, again, it's good stuff that they're aiming to understand before CHORD comes online. Now, just for a very brief snapshot of its status, like I mentioned, CHORD has been in motion for some years now. The very first official announcement, I think, was essentially in 2019 when folks in Canada, when I was still in Canada helping to build CHIME, put out their Canadian version of the AAS white paper series, or the decadal survey, so to speak, called the Long Range Plan, where they essentially announced the instrument and basically started to put in motion all of the development of technologies, whether it be the receiver, the low noise amplifiers, or the various parts of the analog chains, as well as the actual digitizing hardware and the actual actual engine, so to speak, for producing the data products that are meant to go toward the cosmology team, the FRB team, the pulsar team, etc. And a lot of work has actually been spent on refining the optical design of CHIME in terms of developing dishes, resin-based dishes that are being developed to be, not perfectly, but reasonably well calibrated for the cosmology experiments, of course, just given the nature of the measurements they seek to make. But the nice thing about the development, specifically, for example, this deep dish development array being led by folks in Canada, McGill and Calgary, etc., that effort has directly translated into basically the efforts to put in the CHORD Pathfinder, which is a smaller scale version, as the name suggests, of the full CHORD array. It's going to be up to 64 dishes, I believe. So a fraction of the total core, but nonetheless one that's meant to demonstrate the proof of concept, ensure that whether it's things like data rates, etc., we can handle all those things, and that the specifications can be achieved at that specific scale. And so the first dish installation, actually, for the CHORD Pathfinder, shown on the right there, was actually just placed about a month or so ago, I think literally January 15th. And the goal is to have the Pathfinder installed over the next half a year or so, with the intention to let it run and configure it and operate it, again, to demonstrate its effectiveness. Now, I think I got the impression that folks had spoken about these on some level, but one of the other quote-unquote informal pathfinding efforts has been the effort to develop outrigger stations for CHIME. Again, as you can figure, given the nature of outrigger station, these essentially autonomous and independent VLBI stations that are meant to receive triggers over Ethernet, etc., and record data and transport them, presumably over Ethernet as well. It's a fairly monumental task in terms of all of the infrastructure that you need in place for such things to occur, and a lot of that work is being ironed out through the CHIME Outrigger program. So even though CHIME and CHORD are technically distinct entities, there's a substantial overlap, very natural overlap, and in fact a good amount of the team is basically a part of both efforts, or at least focusing on CHIME, which intends to work on or share technologies with CHORD. So whether it's the actual construction of the outrigger stations, which several folks in this audience have helped build, or the science that is starting to come out with the outrigger stations, we're slowly but surely demonstrating that such efforts, while monumental in a lot of ways, are feasible and worthwhile. And I think that is the last slide I have up before, so I'll happily take any questions. Thanks for your time.
A reminder, we're prioritizing kind of student questions first if we can, but other than that, we have a full 10 minutes, so we went way under, so we have to.
Okay.
Yes, so you said you were increasing the redshift coverage. How many are we expecting to see, like the redshift over 2?
Right, yeah, yeah, it's a good question. In terms of what these histograms are showing, it's certainly not as large as more moderate redshifts, but the statistics are definitely meaningful above a redshift of between 1 and 3. It seems like a meaningful fraction, something like 20% are thought to be coming from those galaxies at those redshifts. So.
When is CHORD supposed to start taking data? When's it supposed to be up and running, fully?
Yeah, of course. No, it's a good question. And forgive me, that's a natural thing for me to put in the slide, but I typically didn't finish putting my slides together, but it's totally fine. So I think the intention is for the Pathfinder to go in and be operational by fall of this year, have it operate for at least 6-ish months or so, maybe up to a year tops. Because during that time, as the various teams focus on making that work, others will continue the development of the other components. But the intention is to have first full light, so to speak, within 2 years from now. Yeah. So whether or not that happens, I think CHIME had naturally a delay in itself, so 2 years plus 4, 1 to 4, we'll see. But I think the intention is to have it operational by the end of 2027.
I apologize if you said this.
No.
Maybe you did and I should know. But are the FRB detections going to be released immediately to the whole community? And if so, how quickly? What's the
For sure, yeah.
like?
No, that's a good question. So one of the nice things about CHORD is that it's much more formalized in terms of its governance structure and various policies related to it. As far as releasing data, I think because there is such substantial overlap with CHIME, we will almost certainly port over stuff like Thomas has worked on with view events, so alerting the community essentially instantly above some reasonable threshold, like, hey, we see all these events and so on. As for data sharing, again, I would like to think we're reaching an era where it'll become also immediately possible, like the DSA, I think, will actually share data once it's downlinked and reported. But I think the sharing of that information, I think, will become much more. I don't know strictly the answer, but I believe there will be openness to sharing it essentially.
Yeah, just thinking about multi-messenger follow-up. You will have MOUs with specific teams that get access to localization data immediately, or if it's just going to be, hey world, here are these localizations.
Totally, no, I think so. For example, CHIME has active MOUs with, for example, LIGO. And I think the MOU is specifically for sub-threshold events, so things that are marginal but nonetheless, things that we can record, because we do record various types of data products for for very faint events within some very low signal-to-noise threshold range. We'll record the metadata, like the actual detection data, and depending on available storage, we may even downlink the data, because we do tend to find that there really are a population of fake sources. So a lot of those MOUs are geared towards those fake things where maybe other teams have detections as well, or at least have data sets that could allow for correlations and so on. But I would say for sources above a signal to noise of say 10, I would, or whatever the threshold is for view of. Do you know what it is, Thomas?
12.
12, yeah. So for any detection above 12, I imagine we're going to be learning the community on detection.
Can you clarify what's going to happen to CHIME after CHORDs come online? Is it going to be the commission, or are they going to operate together?
That's a very good question. It's made grant writing very difficult because I think the idea is that CHORD is meant to be a successor to CHIME, but because, and I didn't even emphasize it in my slide, so forgive me, but the intention will be for CHIME and CHORD for at least 5 to 10 years, say, to operate together. Because CHIME, its strength is that it's not as sensitive as CHORD, but it has a much wider field of view. So you can think of CHIME as a shallow but wide instrument, and CHORD is a narrow but deep instrument. And so having the two of them work together is really interesting for like a population-based sort of to try to get a sense as to, again, the fields of view are not the same per se, but the statistics will be comparable, if not better, with CHORD than with CHIME. So the intention is to have them operate together. There's been active work to ensure that CHIME continues operating for the foreseeable future, basically, because of all the science that it's doing beyond the cosmology.
Yeah, thank you. That's great to hear. Also because if I saw them up correctly, you're probably going to be cutting off any chance to co-observe from the southern hemisphere with CHORD, right?
Right, yeah, so given the placement, yes. Yet another figure I should, sorry. Yeah, so given the placement of the observatory, CHIME itself technically is barely exposed to a declination of -20, so we don't even get to like the galactic center or anything like that. CHORD, because it's going to have this dish design, the idea is that CHORD will basically point at some declination and then let the sky drift overhead. So it will have these strips of observed sky per day, basically. But CHORD will basically not move as well. So you basically will park it there and leave it there for some months in order for all the teams to acquire the data as necessary. But it won't even go below, I think, a declination of 0. So the southern hemisphere, for sure, won't really be explored. And in reality, that's where instruments like HIRAX, for example, will be really important once it comes online to do something like what CHIME is doing for the southern hemisphere. That's good.
When I stopped Emmanuel, I thought that the single dish has a field of view of 12 degrees, right? Or is the full array of dishes that has a field of view of 12 degrees?
So because of how wide the band is, I think at the bottom of the CHORD band, which is 300 megahertz, I think the field of view is estimated to be somewhere like a little over 100 square degrees or something like that. But at the high end, at 1500 megahertz, I think it goes as low as like even below 10 square degrees. So it's a pretty wide order of magnitude swing in terms of where it's
I should set the center of the band.
Oh, yeah, I see. Yeah. So somewhere in between.
So we're not actually using it as a tiled array. We are basically making a waveform. There is no plan of tiling the individual dishes as well. Same.
Oh yeah, the idea is that all dishes will be acting together and basically pad their shared field. Like they'll all point to the same place, and then you'll just fill the field of view with tide array beams, as is done with CHIME, but they're much like kind of common.
So I have a nice question. So how efficient CHORD will be to detect repeaters compared to CHIME?
How efficient will CHORD be to detect repeating echoes?
That the field of view is considerably smaller than.
Yeah. No, that's a really good question. So I think, yeah, that's a good question. I can't comment on sort of the population level type of, how many more will we find and so on. But I think given the fact that, again, when you take all of the elements in the array, so to speak, point them at the same part of the sky and then park the instrument there for months on end, it'll be good, in that sense, it could be good to detect repeating FRBs, assuming there's no, especially long periodicity to them, right? Because that's kind of a big question as to, some repeaters show hints of periodicity, if not strong evidence for it. So depending on those timescales, it may be good or not good, depending on, whether or not they are intrinsically periodic, and if they're periodic in the order of months, then, we'll see one or several bursts, but then we may never see it again, or at least maybe not see it for a while until we return to that part of the sky and so on. So it won't be as efficient as CHIME, because just given how exposed CHIME is. But the sensitivity may help in detecting, sporadic kind of tree-like or forest-like bursts of forests like bursts that has been seen in other. There's an interplay.